Okay, we're finding the area between a couple of curves again, and they give us some nice simple curves this time, x squared and x cubed. So let's take a closer look at what's going on here. X squared is a parabola, of course. It starts out horizontal and curves up like that. That's our x squared. Now, a cubic comes along like this. Kind of a superficially similar shape, but it turns out a cubic takes a little longer to get going. It's lower at first, but then it starts to grow faster and it eventually catches up with and passes x cubed, like so. And so we have this area here, which is what they're looking for, which begins at the origin when both curves are 0. And there's area in this space all the way up to some point up here where x squared and x cubed cross again. So we need to find where those 2 points are before we can do anything else. We're going to build our integrals around the locations of those points. So the question is, where do x squared and x cubed cross? And that's not too hard to find. If you say x squared equals x cubed, you can turn that into a function that equals 0, because for polynomials that's usually a good idea. Pull out a common factor of x squared, and we get there are 2 solutions. X equals 0, which we knew already, that's saying that these cross at the origin, and also they cross at 1. So these curves cross again at the point 1, comma 1. So that means the integral that we're going to do to find the area between them will be an integral from 0 to 1. That's where this area begins and where it ends. And this integral will have a dx at the end of it, of course. They pretty much always do. And what's our integrand? You remember it's supposed to be the upper bound, like the top of our region that we're finding area for, minus the lower bound, or the bottom of the area. So in this region, the higher area is actually the x squared. And the curve at the bottom is the x cubed. And so this is the heights of our rectangles, or what we call the difference function sometimes, x squared minus x cubed. If you're setting this up and you're feeling a little wobbly about the order to put in here, don't worry about it too much, because if you get this order wrong, all that will happen is your area will come out negative. And then when you see that negative, you'll say, oh, I set it up backwards. And if you just throw away that negative, you'll still get the right numeric value as long as you've got a single integral here. So in this case, though, I think we do have it right, x squared minus x cubed. Let's see what the calculus gives us. Our antiderivative is going to be 1/3 x cubed minus 1/4 x to the 4th, evaluated from 0 to 1. So if we put 1 in this, we get 1/3 minus 1/4. If we put 0 into this, a wonderful thing happens. We get a bunch of zeros, and so that section just vanishes. 1/3 minus 1/4 is 4/12 minus 3/12 is 1/12. So that should be our area. So nothing really new on the calculus side, just the fact that sometimes you have to do a detailed sketch to figure out which curve is higher and where is our area going to begin or end, which means finding points of intersection. You already know how to do that, and if you've forgotten, well, you'll get to practice a fair bit in the next few hours.